guys, Miss Isbell here. I'm going to walk you through real simple of what we see in the light reactions, which is going to be the first step to photosynthesis. Now, when we're looking at the light reactions, we need to know that it's going to be taking place in the thylakoid membrane here, which is what we see these lines are. Down here, this is the stroma. So this is going to be surrounding the thylakoids, which we're going to see the thylakoid interior space is going to be up here. Alright, first thing that we need to know in the light reactions are step number 1. If we can see this here. Number 1. Light is going to come in and it's going to enter photosystem 2. Now it's really important to note that photosystem 2 is going to be before photosystem 1. So light strikes photosystem 2. In photosystem 2, we see that there is water in photosystem 2, and the light is actually going to break it down into hydrogen and oxygen. Not only is water breaking down, but water is going to donate 2 electrons in photosystem 2. Now these electrons hitting and absorbing the light, they are going to have lots of energy. They're really excited and they want to move. These electrons are going to be passed through these proteins on the thylakoid membrane all the way over here to photosystem 1. Now, as these electrons are being passed, we see the path that they take is called the electron transport chain. And we can go ahead and abbreviate that, the ETC. So, real quick. Step 1, light strikes photosystem 2. Step 2, water is going to be breaking down into hydrogen and oxygen. Not only is it breaking down, but it gives 2 electrons to photosystem 2. These electrons have lots of energy and they want to move. So step 3 is these electrons move through the ETC to photosystem 1. Now when they get to photosystem 1, they don't have a lot of energy. So we see that light, step 4, is going to come in and it's going to strike these electrons and it's going to re-energize them. These electrons are going to keep moving and they are going to be passed on to our bus driver, which we call NADP+. When NADP+ grabs these 2 electrons from photosystem 1, it's going to turn into NADPH. Now, our bus driver with these electrons, their job is to then leave and they go to the Calvin cycle. I'm just going to abbreviate it CC here. Now, that would be step 5 for us. Our very last step, step 6. Inside the thylakoid, we see there are lots of hydrogen floating around, and we don't see a lot of hydrogen out here in the stroma. And we know with diffusion, we see molecules want to move from a high to a low concentration. So we see hydrogen are going to want to move through this protein here, and this protein is called the ATP. I'm going to move this over here so you can see it. ATP synthase. And we know synthase or synthesis means to make. So as hydrogen is going to move through ATP synthase, it's going to cause it to spin, and as it's spinning, we see ADP is going to store energy, so now it turns into ATP. This ATP is going to leave and go to the Calvin cycle. And again, I'm going to abbreviate that CC. So, let's just walk through this again. Let me slide this over. Light reactions are very, very, very first step. Light is going to enter photosystem 2. When light strikes water, water is going to break down into hydrogen and oxygen. This oxygen is free to leave, it's no longer needed, and it's going to diffuse into the atmosphere. Water is also going to give 2 electrons. Now these electrons absorb this energy from the light and they are really excited, so they want to move. And they're going to move from photosystem 2 to photosystem 1, being passed on the ETC. As they are moving, they're losing energy. When they get to photosystem 1, they have very, very little energy and they don't want to move anymore. So we see light strikes photosystem 1 and these electrons get re-energized and they're going to then jump onto our bus driver, NADP+. When NADP+ grabs those electrons, it turns into NADPH and it's going to leave and go to the Calvin cycle. Now our very last thing that we see happening in the light reactions is all of this concentration of hydrogen in the thylakoid wants to diffuse out into the stroma. It's going to move through ATP synthase, and when hydrogen moves through our ATP synthase, that's going to cause ADP to store energy in ATP, which then is going to leave and go to the Calvin cycle.